Okay, there we go. Now we'll start on 2.2. Let me show you the notes first. You gotta remember, all these notes are stuff that you already have on Canvas, assuming you know that. So, definition of a circle. A circle is the set of all points in the plane that are, I don't know what that word is, equidistant. Hmm. From a fixed point called the center. Oh, equidistant. Ah, I see. I've never read it before, I guess. That's funny. Anyway, the fixed distance from any point on the circle to the center is called the radius. So all the points, in other words, equidistant, meaning they're all the same distance around the circle or from from the center, the center point. That's all they're saying. So if one of the points was not equally away from the center, then it's not a circle by definition. So that's how you define the circle. These are different forms of the circle equation. Right here is the standard form that I'm used to. So when it's in this form, HK will be the center. So if it's, let me see, check this out. Negative 4 and 3. Notice how HK are not negative, but here they are in general terms. So that means it has to be the opposite. So if it's negative 4 and 3, then the center has to be positive 4, negative 3. And the radius will always be the square root of this number over here. So if it's in this form, you can see right here, R is your radius. R squared is usually how it comes. Okay. So radius is 5, center 4, comma negative 3. On this one, there's no number on the x or inside the x squared. So your center for that p is going to be 0, positive version of this. So 0, 12, or 0, 1 half, sorry. Radius will be the square root of this, which is right here. This technically reduces, but we're just trying to get some ideas right now. Sometimes you'll have the circle in general form, which is this one right here. So if it's in this form, then you can't just pick out the radius and the center. You'd have to either change it into standard form or use a formula or try something else. Okay. So on number one, what's the center? Okay, well, it is the first one, so that's okay. Whenever I ask a question, I don't know is an okay answer, you know. I have a few friends and family members that just stare at me when I ask a question. I'm like, just tell me you don't know. It's okay. Not a big deal. So we said, right? The center is written as HK. If it's in center form like this, then we can just see the H right there and the K right here. You just need to remember that the standard form has it as negative, but the actual thing should be positive. So the way to fix that is just make it opposite. Okay. So if we have negative 2 as my H, there's the H right there, and my K over here, what would be the opposite of these signs? Yeah, so center is going to be +2, +1. That's all you got to do. Whatever's in here, just switch it. Nothing crazy. Now the radius we said is the square root of whatever's over here. Since it's in standard form, we can just do that. All right, we said if it's in this form, then we can find all this information here. What is the square root of 9? Yeah, it has to be 3, right? So given that information, you can graph the circle. So start with this, go to the center, 2, 1. Remember, the center's not an actual point, it's just the center of the circle. Now, if the radius is 3, that means we're going to have all the points equal distant away from the center, right? So 1, 2, 3. So this is an actual point. 1, 2, 3. 1, 2, 3. There's my radius going all around. I usually do 4. 1, 2, 3. Mainly because I can't draw. But I think if you have a compass, right, 2 points is good enough. There's my ugly circle. But anyway, do you see how to graph it given this information? Can you find the radius and the center by looking at the standard form? Okay, let's try, well, let's check out this one. Is this in standard form? No, which sucks because putting it in standard form is kind of annoying. Let me think. Yeah, I guess I'll just have to show you. Do you remember how to complete the square? I feel like we talked about it in the review a little bit. Review sections. No, we're gonna do it now, so it's not good. Given the equation of a circle, identify the center and radius. So if they don't give it to you in that nice form, we got to do this. Okay, this is what they gave us. So what I recommend is get the x's together, leave a little space, the y's together, leave a little space. And if there's any numbers, move them to the right. So let's set this up. We'll set it up for completing the square. We're going to complete the square for the x variables and the y variables. So I'm setting it up. Remember we said we got to find that magical number that will complete the square. Then we got to do it again for the y's. But whatever we do to one side, we have to do to both sides. Do you remember how we find that missing number to complete the square? I think it was a week ago, maybe. That's a good guess. But we did it around that time. I think it was right after the AC method. Um, so what we did is we remember that the general form was always written this way, right? Then we said to complete the square, add half of b squared. Then it will factor like this, which is the complete square. That's the goal. Because remember, if it's in this form, then that means we're going to standard form for a circle. You see where we're going? So what is half of b for the x term squared? Let's see. Yeah, it's gonna be one, right? With the y terms, b over 2 squared is 4, or sorry, 8 over 2, which is 4 squared, which is 16, right? You guys with me up to this point? Okay. So we need to add this number to that missing blank, but we have to do it to both sides. We can't just add for no reason, right? So let's add this. So add the 1 special number, add the 16 special number. So that'll be negative 13 plus 1 plus 16. What is that going to become? 4, right? So once you complete the square, it's going to factor perfectly like this. That's why we call it square. Square is completed, so it factors like a square binomial. Add all your numbers, we get a 4. So now that it's in this form, what is the center? What is the radius? Yeah, but they have to be opposite signs. So, and radius is going to be what? Yeah, square root of this number. Okay. Any questions on the algebra completing the square? Because once you get to here, it's pretty straightforward, right? Excuse me. All right, I'm gonna move on to something else then. You guys cool on two. All right, move on to four. Give the equation of the circle centered at the origin with radius 7. What does origin mean again? So just the center of your, whenever you graph something, the middle part, the 0, 0, is your origin. So origin is the 0, 0 point on the XY plane. So if it's right there, that means the center is 0, 0, right? So HK is at this point. Radius is 7. So use the standard formula, standard form. So we're going in reverse. So given this information,
So essentially, the H and the K are basically the origin.
yeah, in this example, it is the origin. Mhm. So we just plug in what we have. So this is the standard form. H is 0, K is 0, R is 7 squared. So this becomes x squared plus y squared equal to 49. So that's the equation they want. Any questions on 4? Okay, let's do another one. Write the equation of the circle with center 3 comma 9 and radius 5. So that means that HK is 3, 9, R is 5, right? Standard form. Plug it all in, and we're good. Any questions about number 5?
Nope, I think I'm following.
So they want this. So if you have the center and you have the radius, you're pretty much good. Now, they can make it more complicated, right? Because they always do. If you don't have this, the radius or don't have the center, you're gonna have to figure it out. You guys cool on 5 before I move on? Okay. So find an equation of the circle that has a center of 0, -5 and passes through -4, 3. So we don't have the radius. We have the center. So there's two ways to solve this. What would y'all do? Or do you have any ideas? Nope. Yeah, we could plot it. In the last two examples we saw, if we have the center and the radius, you can find the equation, right? That's all we need is the radius. If we were to plot it, maybe you could see the radius by counting, unless it's a decimal or a fraction, then you really can't. We have HK, and we have some random X and Y point, right? Nothing special. We just know it's on the circle. So couldn't we just plug everything in and solve for R? Or to plug in the X, which is -4, right? Minus the H, which is 0. Plug in the Y, which is 3, minus the K, which is -5. So you could solve for r at this point, right? 3 minus 5 is 3 plus 5, 8. 8 squared is 64. Negative 4 squared is 16. That looks okay, right? 16 plus 64. What's that going to be? Yeah, it's going to be 80. It is not a perfect square, so if we were to plot it, we wouldn't be able to get the exact number by counting. It's going to be some decimal. So we'd have to square root both sides. So r is equal to square root of 80, which can be reduced. Hmm, what goes into 80? What's the biggest squared number? 16? This calculator doesn't work. Let's see. Yeah. 80 divided by 16 is 5. So we can reduce it. Whenever we reduce radicals, we want to factor a perfect square. So the square root of 16 is 4. So this is the prettiest it's going to get. So x minus h squared plus y minus k squared equal to r squared. Plug in our stuff. H is 0. Y is negative 5. Although it might be easier to leave it as 80, because check it out. I forgot, they're not asking for the radius, so just leave it as 80. Any questions on what we did? Because if you have radius and center, you can find this equation. So we had to solve for radius. Okay, let's do one last one first. This is for 2.2, and we'll take the short break. Find the equation of the circle whose diameter has endpoints -2, -1, and -6, 5. So this time we don't have the center, we don't have the radius. We have 2 points on the that forms the diameter. There's a couple of ways to do this. How would y'all find the center? Which formula would help us out here? We could find the distance and then cut that in two, right? Because that would be the radius. But we could also do the midpoint, and that would be the center, right? But either way, we could do midpoint or distance. But there's quite a few different ways to do this. The midpoint formula, I think, is a little bit easier, but it doesn't matter. So -2 plus -6 over 2, -1 plus 5 over 2. That'll be -8 over 2, 4 over 2, -4, 2. So the midpoint will be the center in this example. So HK is equal to -4, 2. So we can find the radius the same way we did in the last example, or you could find the distance from here to the edge, one of the edges, to find the radius. Doesn't matter though. Like I said, you can use the distance formula, midpoint. It just depends on the situation and which you feel is easier. And these are on opposite ends of the circle, so you could use either one with the distance. Well, let's try distance this time for fun. Use the distance formula to find the radius. Use the center and one of the edge points. Doesn't matter which. I'll use, I guess the one that's both negative. I don't know. We'll call this x1, y1, x2, y2. So the distance would be the square root of x1 minus x2 squared plus y1 minus y2 squared. Plug it in. That's going to be -4 minus a -2, it's then squared. plus 2 minus a negative 1, then squared. Now, I think the distance formula had x2 minus x1, but if you're consistent with both of them, it'll still work because I'm going to square it. So that'll be negative 4 plus 2, so that's negative 2. 2 minus minus 1, that's plus 1, that's 3. So that becomes 4 plus 9, which is 13, right? So R is root 13. All right, and then that's it. Plug everything in. X minus h plus y minus k equals r squared, which implies we're going to get x minus negative 4 plus y minus 2 equals root 13 squared. So that becomes x plus 4, y minus 2 equals 13. So you choose which formulas you want to use, as long as it makes sense, you'll be good. And if you don't mess up the algebra, of course. Any questions on number 7? Okay, I'm going to check on the syllabus, see where we're supposed to be at. Let me pause. All right, so we need to understand the definition of a function. The first definition is for a relation. So a set of ordered pairs, x, y, is called a relation in x and y. If the set of x values in the ordered pairs is called a domain of a relation, and the y values are the set called range of the relation. Now, a specific type of relation that matters is a function. But this is very specific. So given a relation of x and y, we'll say that y is a function of x if each value of x in the domain, for each value x in the domain, there's exactly one value y in the range. So basically, if you put an input into your function, it's assigned one output, a y value. Okay. Uh, a function may not have the same x value paired with different y values. So that's one easy way to determine if it's a function or not. However, it is acceptable for a function to have two or more x values paired with the same y value. You can use a vertical line test to rule out graphs right away if they're functions or not, which we'll do in just a minute. But check out these examples. It's very visual. Do you notice how all these x's are all these inputs in the domain? These would be considered your x values, are going to one place, right? Like none of them go to two different places. Like R goes to -8, K goes to -8. None of them goes to two spots. So this would be a function. All right. Look at relation 2. Do you see how E goes to two different spots? So because E has two different outputs, it's not a function. That's the easiest. That's what we're basically looking for a violation of the definition. Every X is assigned to one Y value. Every domain value is assigned to one range value. This one does not have one range. Okay, what about three? Relation three. Yeah, they're all unique, right? And none of them, it does, nothing repeats itself, so it will be a function. Relation four, does anything repeat? Is there one X value that goes to two different places? They're all unique, right? All the domain values. So it is. Okay. Now let's look at graphs. These are easier to see because you can apply the vertical line test. If you draw a vertical line anywhere and it hits 2 points, it is not a function. So this one is no. This one hits two different spots. Two spots. So no. What about number four? What do you think? Yeah, it looks like if I draw a line through these 2 points, I hit two spots, right? So no. This one looks good, right? No matter where I draw it, I'm not going to hit two. What about six? Will any vertical line hit 2 points? Then we're good. So first four are not functions, last two are. Any questions on number two? So that's what the vertical line test is saying right here. Consider a relation defined by a set of points. The graph defined y. So no, if no vertical line intersects the graph in more than 1 point, then you have a function. So the y graph defines y as a function of x if no vertical line intersects the graph in more than 1 point. So if you have the graph, just look at it, draw a vertical line anywhere you want. If you hit two spots, you can rule that out as a function. It'd be a relation, but not a function. Okay. So here's just some notes. You can look into this deeper, but the way you read it is f of x. This is not a multiplication, it's a notation. So f with an input of x is equal to x minus 2. So they're telling you to avoid a mistake. It's not a product, it's a notation. Okay. Now let's work on number three. Okay. Example three is just basically trying to get you used to the notation. So given, let's see here, f of x equal to the function f equal to 4x squared minus 2, g of x equal to 4x plus 4. Find f of negative 4 and f of, I'm sorry, g of negative 3. So when you see that, they're asking you to plug it in. So f of negative 4 means plug it in wherever you have an x. Let's see what happens. G of negative 3 means plug it into the g wherever you have an x. Does that make sense? So they're just asking us to find these two things. 4 times 4 is 16 minus 2. 4 times 16 is 64 minus 2, 62. Plug in negative 3, that'll be 4 times negative 3 plus 4. So you would say that f of negative 4 is equal to 62. G of negative 3 is equal to negative 8. This is also the same as saying the point negative 4 comma 62, negative 3 comma negative 8. Are there any questions on example 3? So if you see this notation, you know what they're asking, right? 4, 5 are the same thing, it's just different types of functions. Let me show you, but I'm going to skip some of them. You can do one though if you like. So check it out. They give me a g function, they're telling me plug in negative 5, see what happens. Number 5, give me a f function, plug in negative 5 into the x's, see what happens. Would you like to do any of these? 4, 5, or 6? It's the same as 3, but I don't mind doing another example. 5. Okay. Oh, shoot. Yeah, we can do 5 and 6. Sorry, just saw your message. We're going to share the screen here. I'm going to rewrite this question though. Okay. So let's write the function first. I'm getting ahead of myself. They said f of x is equal to this rational expression. And then they said find f of -5. So just plug it in wherever you have an x. -5 minus 7 is -12. This is 25 minus 50 plus 16. And that's pretty much it. Just crunch the numbers. -25 minus 50 is -25 plus 16. What is that? T negative. At 9? Yeah, thanks, man. So these are both negative. They'll become positive, and then this will reduce. So 4/3. But you see the idea is pretty straightforward, right? Just plug it in wherever you have an x. Here's all the x's. They said f of -5. The -5 is my input. 4/3 is the output. In other words, we have the point -5/4. Any questions with, for example, 5? On the graph, 4/3, you'd have to use, um, I would probably just recommend using decimals. 4/3 is what? 1.333, right? So approximate, all you can do is approximate it on a graph, so can't be perfect. There should be some tolerance in the program. Like Moving on. Number six. Given f, g, and h, it's the same thing, just different functions. It looks like it could be harder, but the idea is the same. There we go. Oops, I'm off crooked. Find these inputs. So f of 6 will be 2 plus square root 6 minus 1, which is 2 plus square root 5. There's nothing else I can do. G of 6 means plug in the 6 for this function. That becomes negative 6. Absolute value means whatever's in there must come out positive. Multiplied by a negative makes it negative again. That'll be the output. And then if they ask, this is the point 6 comma 2 plus root 5, whatever that is. This is the point 6 comma negative 18. H of negative 2 is going to be negative 4 negative 2 plus 2 over 2 squared. Negative 2. So that'll be a negative 4 times 4 plus 2 over 4, which is what? 16 plus 2 is 8. I'm sorry, 18. No, negative 16 plus 2 is negative 14 divided by 4. Yeah, that's as good as it's going to get. Any questions on the idea? The note. This is basically testing or trying to teach you the notation. Like, do you know what this means? H of negative 2, G of 6. The rest is just algebra, right? All right, let's move on to something else. Well, one last thing, I guess. I'm going to do part of number 8 just so you can see it. Second. Okay, so we all understand that if it's in the parentheses, it's asking us to plug it in, right? Is there any confusion about that? So no matter what it is, you just plug it in. Could be whether it's f of 0, f of y, or f of x plus 8. You just plug it in and see what happens. Don't overthink it. If it's a 0, well, it all becomes 0 times whatever it's doing, right? If it's a y, well, I guess they're all going to switch to y's. That makes sense. If it's x plus 8, we'll plug in x plus 8. I don't know. See what happens. Don't get intimidated by anything. Just try it. You know the rule, so do it. Does that make sense? Now, technically, we can do a little more algebra here because you can square this. That'll give us this. First two terms squared gives me a trinomial. Distribute the -2, that would give me this. And then you combine like terms. So you could do some algebra here. 16 minus 2x. 64 minus 16 minus 1. What's that going to be? 54. The 47. So whatever's in the parentheses, you just plug it in, see what happens, and then do your algebra. Is there any questions on that idea? So I'm going to move on to something else. Or any questions on this algebra here? All right. We're going to move on to ideas about domain and range. Remember we said the domain is a set of all x values or all input values. Okay. So if you were to look at G, what is the domain? What are all the inputs? Just gonna write D as a set, squiggly bracket. What are all the input values? Excuse me. Yeah, all the x values. That would be your answer. So we got 6, 5, 6 repeats again, so you don't have to write that again. 2. Now, when it comes to sets, you only write elements once. So they want the set of inputs. This is my attempt at one of these brackets. So we got, they don't have to be in order, but I'm just going to. 5, well, actually, I already screwed up. 2 is the smallest one. Again, it doesn't matter. It's like writing a list of people in your class, right? You don't repeat the same name. It's still the same person. Assuming you don't have the same person, two people named the same thing. But if that were to happen, might not be a function. Hmm. Range would be all the y values. What are the y values? Yeah, we got m n 0 2. Order doesn't matter, just writing them down. Nothing repeated, so that's it. So that's what they mean by domain and range. It might not always be a set of what's it called? A set of coordinate pairs or ordered pairs. It could be just a function. If they give you the graph or the function, you got to figure out, okay, what is the domain? What are all the x values that I can use? Okay. But finding them all is difficult. So the easy way to do it is find out what is not allowed, because then I can rule everything else out. So what I'm going to recommend is just we graph this so you can get a better idea. Let me find the grapher. Can you all see the graphing thing, Desmos? They call it H, which I guess is whatever. X squared plus X minus 56. X squared plus 17X plus 72. So this is example 10. So just by eyeballing it, do you agree that it hits all the X's, all the positive X's, right? To the right, it just keeps going. And then it hits all the negative X's. So if you know what the graph looks like, you kind of get a feel for, well, the domain's going to be almost everything except the problem areas. We have a division by 0 right in the center. So when that happens, when we have asymptotes, we have to rule that out. So everything's cool except that X value. Now for the range, Do you agree that it doesn't skip anything? It just shoots all the way down and shoots all the way up. And it hits the zero, so the range is everything. Do y'all agree? So on this one, the one that's a pain is going to be finding the asymptote because we got a factor. I mean, it's not hard, but it's just we got to do some work. Well, you can pretty much get the entire answer from the graph, but um, well, let me write one more thing before I move on from the picture. So we're gonna have three chunks, or maybe two. So the domain is gonna be this chunk, right? Negative infinity all the way up until that number here, which I think is what, I don't know, something. Then everything after that number and forever to the right. So that would be the domain. Those you're gonna union those two parts. Okay. Okay. Example 10. Oh, I forgot what the question was. Given the function h, find all values not in the domain of h, which is that problem area we saw in the graph. That's what they want. In order to find it, you have to factor this trinomial using the techniques from back in the day, or the ones we talked about on day one. Does that factor pretty on the bottom? I think it does. What are factors of 72 that add up to 17? Yeah. Use trial and error because there's nothing on the x squared. Hmm. Negative 56, factors of negative 56 that add up to 1. What would that be? Excuse me. Yeah, has to be. But we're going to make the bigger one positive because I needed to add up to a positive. But notice these cancel, right? That's why we don't have two problem areas, we only have one. So x cannot be 9. Let me double check that before let me look at, I forgot I have an answer key. No, actually it wants both. My bad. Let's show the work then. So technically you can cancel it, and that's why I didn't show up on the graph, but it's still a problem in the domain. So the way what you would do, right, whenever you have this type of function, a rational function, meaning a fraction type, check, is the bottom ever going to be equal to zero? And if so, those are problems because I can't divide by zero. So figure out when is this equal to zero. Do your algebra like we did earlier. Set each one to zero like we showed it in our first lecture. So we'll solve this. So so these values make this zero, but we cannot have the bottom be zero. So the question is, well, what is not allowed in the domain? Well, these two are not allowed. Does that make sense? So if those are not allowed, you can find the domain. So basically, the domain is going to be this line here. So we can't have -9 is a problem. -8 is a problem. We have holes there. Everything after is cool. Everything in between is cool. Everything before is fine. So this section would be -infinity all the way till -9. The inner part would be -9, -8. The after part is -8, infinity. Remember that parentheses means everything between but not the endpoints. Brackets means starting at the endpoint. So this would start after -9 and before -8. Yeah, remember that, the parentheses and brackets. Excuse me. So the domain would just be these pieces, just combine them together. That would be your answer. If they ask for domain, right? All they ask is what's not in the domain, but since they're going to ask this on the next question, let's just do it all at once. So this right here, values not in the domain. This would be the domain by working around those two problem areas. But on the graph, you couldn't see the both problems because it canceled. So we had to set the denominator equal to zero, find the values it cannot be, and include everything else around those two values. That's how you find domain for rational type. Is there any questions on number 10? So anytime you have this type, set the denominator equal to zero, find your values, build your domain around it. That's all we did. So I did 10 and 11 kind of at the same time. Let's move on to a different type, number 12. So you're basically trying to, whenever they ask for domain, you're trying to figure out what are the problems and what is not allowed. Because if you know what's not allowed, then you know what is allowed, right? Example 12, find the domain of the function So in square root functions, what is not allowed to happen? Because that's what you need to know whenever you start these types of problems. Whenever they ask for domain, you got to figure out, okay, is there a section where that's a problem, right? Yeah, we can't have anything inside that will result as a negative. You could plug in negatives, but it better not end up a negative. So the way you answer this or find the problems, the problem area, is solve this. Make sure that the inside is greater than zero or equal to zero because it can be zero. You can square root zero, no problem. If I add 4 to both sides, you get x greater than or equal to 4. So this is basically telling you what the domain is. So the domain starts at 4, solid dot or bracket, and keeps going forever to the right. So this is bracket 4, infinity, parentheses. Always have parentheses on infinity. So the domain is everything above or equal to 4. So if you know what the issues are, find out what causes that issue, and the domain will be everything else. Does that make sense? Does that idea make sense? You can always graph them to kind of give you an idea. Most of the time, the graph will tell you the answer. But the last one, it technically didn't. It gave us a good idea, but um, wasn't quite right. On this one, though, it would be right. Yeah, any infinity is always going to have a parentheses next to it. Okay, so here the lowest x value is 4, and you can tell it goes on forever, right? So the domain 4 to infinity makes sense. But we put the bracket on 4 because we actually start right on 4. There any questions on domain? Do you see it just depends on the function type? I'm going to send you, I don't know if I already did, but uh, the parent functions. That way, you know, you have an idea what each type looks like square root, um, rational types, etc. Any questions on 12? 14 looks kind of weird. Let's do that one. They changed the sharing. So check this one out. What problems can you see just by looking at it? Isn't this like a rational type and a square root type at the same time? So what are some issues you guys see with this function? The four's just hanging out. So it's a rational expression, right? And we said we have to worry about zero at the bottom. So whenever you see a fraction type and an x at the bottom, think, okay, whatever makes the bottom zero is a problem. But then when you see the screw, you should be thinking, oh, whatever makes that inside negative is a problem. So I have to figure this out. So that means that the inside of the root must be greater than zero. It cannot be equal to zero. So long as all our inputs listen to this, then we're good. So solve this and you'll have all the x's that'll be good. That'll be fine. So subtract the two. X is greater than negative 2. Okay. So if on a number line, negative 2 is a problem, everything after is okay. So you would put a parentheses and everything after be infinity. Yeah, earlier we said it was okay to be equal to 0, but this time we can't. It has to be above 0. That's why we had a bracket before. Now we don't. Because negative 2 would zero the whole bottom out, which is an issue. Okay, so domain is just that. That's the only problem, sir, as long as I don't violate that issue I mentioned, making this negative or 0, then we're good. Any questions on 14? So I'm gonna just go over this together just in case. 16, can you guys see it? Okay, so they built the formula for us, which is cool. They said Chow received $30 gift card. He used it to buy prints for 7 cents each. So right here, he starts with $30, and every time he buys a print, he loses 7 cents times the number of prints. That's why they created this equation. So they made basically a balance function, and eventually it's going to zero out, right? So the question becomes, what happens when I buy 40 prints? What would you do to solve this? Yeah, just plug in 40. What is that going to be? Looks like 27.2. $27.20. Any questions on what they're asking? It's straightforward, right? 17 is similar. Just plug in or solve for what they asked for. So I'm going to move on. Okay. So now they're asking, do you understand what f of negative 2 or f of x equal to 4 means if you have a graph? What does this mean again? Just did it a whole bunch, right? So we said x is 4, negative 2. Oh, I think it got it backwards. So when x is negative 2, what is the y value? That's what this is saying. So if x is negative 2 and I plug it in, what would be the output? I don't have the function. So go to negative 2. What is the y value? Yeah. So the output is 2. Now, if the y value is 4, what is the input? What should I write that? Hmm. So the answer would be y is 2 for the first for this part, and this would be your x, right? Any questions on 18? Okay. We'll move on then. Given these 3 points, what's the domain? In other words, what are the all the x values associated with these points? Yeah, it looks like just -4 for those first two on the left, and then -3 for that other point on the bottom. And then the range are all the y values. What are the y values? What do you think? 3, -4, but we also got -1, right? Okay. Any questions on 19 or 20? No. Okay. Um, 20. What's the domain? Actually, it's going to be an interval, not a set. What's the lowest x? Because that always goes first, the most negative or the lowest, right? The most left x, right? Furthest it went to the left is right here. So that x value is -3. So a bracket, because we have a solid point there. And then we keep going all the way to the right up until this point. This is the furthest to the right, so that's the largest x value. But there's a hole, so you put parentheses. Any questions on how we found domain? Okay, range, what's the highest value? Oh, we'll first start with the Lowest. What's the lowest value on this graph? Yeah, on the y-axis, it looks like bracket on -4. What's the highest value? The lowest, highest, right? So whenever you're doing range, it's just going lowest point to highest point, domain, leftmost point to rightmost point, and figure out if there's any brackets or parentheses, or if the function skips or jumps, because then you'll have to add pieces or do pieces at a time. Any questions on 20? Okay, just let me know. I think I'll stop here. Do y'all have any questions on 21 or 22? Do you see the idea? Okay. Well, we'll stop here then. Me take roll and then we can call it a night. I think we are now a little bit ahead. Next week we'll finish the material for test one, then review. So I think what I'm going to do is record a review for you. That way we can just focus on two sections next time. Although you can always bring questions about the review. I'll try to send it right away though. Hmm. Okay, roll, we said. All right, is Jonathan here? Yeah. Adrian, not here. Ayush, there you are. You're here. Tiaras, Bree's here. Amanda, Mark is here. Omari is not here. Angel Rivas, not here. And Jasmine is here. Okay. All right, guys. I'll stop here. If you have any questions,